The last thing we're going to talk about is what happens when kind of weird things happen, or what to do when weird things happen when you're solving with elimination, okay? So these last two examples, you're going to notice there's something strange that happens, and we just need to talk about what to do when that happens, okay? So these are special cases. So in number 7, you're going to start it out the same way. You got to make sure that everything's lined up. Then you're going to check to see if your X's and your Y's have the same number with different signs, or either one of them. So when I look, it's not happening, so that means I'm probably going to have to do the flip-flop method, or I'm actually going to show you another way to approach it. You can do the flip-flop method. There's nothing wrong with that. But if you look at an equation and you figure out you just have to multiply it by a certain number to make that happen, then you could also do that. Because remember, your goal is just to get them so that they have the same number with different signs, okay? And so as long as you can reason through it to make that happen, then you're good. So when I'm looking at these equations, if I'm looking at the X, I notice that if I just take 6 and I multiply it by 2, I'll get 12. And so I'm just going to multiply it by 2, but remember, you have to take it times the whole equation. But then at the same time, also, you have to have them with different signs. So what I'm going to do is I'm just going to take this one and I'm going to multiply the whole thing by a -2, okay? Because that'll make it have the same number with different signs. Okay, so again, if you notice that that's happening and all you have to do is just multiply one of them by one little number, then you could do that and it'll still accomplish your goal, okay? So I'm going to take this one, I'm going to distribute my -2, so it'd be -2 times 6x, which is -12x. -2 times y is -2y, and then -2 times 7, I get -14, okay? And notice, I'm going to just bring this one underneath it, that way they're lined up still. When I do that, it makes them have the same number with different signs, okay? And so once I do that, just like all the other problems, you add them together. So -12x plus 12x is 0, so that goes away. -2y plus 2y, ooh, that's 0 as well. So on this side of the equals, you have a 0. And then on this side, -14 plus 14 is 0. So this is what I was talking about. This is why this is a special case. So when you solve, and you probably remember this from other problems, and your variables go away, and you end up with a number equals a number, remember, you ask yourself one question: is that true? Is that true or false? This is not your answer, but it's going to help you kind of know what your answer is. So is 0 actually the same thing as 0? And that is true. So when that's true, that means you're going to have infinitely many solutions. So infinitely many solutions to that problem. Meaning there's going to be a whole bunch of different x and y's that you can plug into that equation that will also work in that one. Okay, so it's not going to just have one solution to it. It's going to have an infinite amount of solutions. Okay, so when this happens and it's a true statement, then your answer is infinitely many solutions, okay? So let's look at this other one. So with this other one, same steps. Make sure they're lined up, and notice this is the first problem we've done where they're not. So the first thing I have to do is get them lined up, okay? So usually we put them in standard form, so that one's already in standard form, so I'm just gonna bring that one over. But this one isn't, so to get it in standard form, I'm going to add my 6x to the other side so that I get my x's and my y's on the same side. So then these will go away. And then I'm going to write it over here. So I get 6x in front plus y equals, and then my 1 is on the other side. Okay. So now I have everything lined up. Then I can look to see, do I have the same number with different signs? And they have the same number, but they don't have different signs. So remember, to do that, you take one of your equations and you just multiply it by that -1, okay? And I'm actually gonna bring my equations down here. So when I multiply by that -1 here, -1 times 6x would be -6x. -1 times y would be -y. And then -1 times my 8 would be -8, okay? And so that's this equation. And then I'm just going to bring the other one down right underneath it. And I'm going to double check. So I just copied that one down. Do I have the same number with different signs? I do. So you can add them. So negative 6x plus 6x is 0, so that goes away. Negative y plus y, that's also 0, so you get 0 on this side. And then negative 8 plus 1 is negative 7. Okay, so notice my variables went away again. You ask yourself the same question. Is this true or false? And 0 is not the same thing as negative 7, so that's false. And so when it's a false statement, that means that there's not a solution that will work in that system of equations. There's not an x and a y that will work in both equations.